First of all, we'll discuss what is correlation. So, this is basically a topic of statistics analysis. So, what is correlation? Correlation, let us say if I have set of two values and these two values due to variables vary in such a way that the change of one variable will affect the change in other variable. So we find the correlation between these two variables. Means correlation is nothing but the cooperation between these two variables. If the change of one will affect the other variable. For example, the income and expenditure, they are correlated to each other. If income increases, then definitely expenditure will also increase. Like height and weight of a particular person. Suppose the height of a particular person increases, accordingly the weight will also increase. Now, in other words, we can say that correlation is nothing but the coordination. Now, here we calculate the coordination between these two these variables. So there are three things which we have. One we call as when the correlation is a positive, when correlation is a negative, and when there is no correlation, you can say zero correlation. If the values will increase in the same direction, if the values of the two set of variables are increased in the same direction, then we call that the correlation is said to be a positive correlation. And if these values varies in opposite direction always, then we call it as a negative correlation. And if there is no coordination between these two values, then we call that there is a zero correlation. Let us say I have some set of values. Let's say I have some x and y, and if the trend will be like this, that when x changes, y will also change, and the trend is in same direction, then we call it as a positive correlation. And if here only, if x changes, y will also change, and the trend is in downward direction, and trend is in downward, see, x increases but y decreases, they are opposite to each other, then we call this as a negative. And when there is no relation between x and y, then we call it as there is a zero correlation. So here what we do, we are calculating coefficient of correlation. We are calculating the here coefficient of correlation. Now commonly we write this thing by a word small r, and this small r lies between -1 to 1. So if (1 to 1). So if r is equal to 1, then we can say the correlation is said to be positive, and if r is -1, then we said that the correlation is said to be negative, and if r is equal to 0, then we can say there is no correlation between this. So here we are following in some kind of trend here. Okay, so we have three methods of finding correlation. One is the scatter diagram method, by the help of which we can find the correlation, coefficient of correlation. Second method is called Pearson coefficient of correlation. And the third one, that we call as a rank method for finding the correlation. So 3 methods for finding this correlation. Okay, so we will discuss these 3 methods one by one. So the first thing that will come into mind, that what do you mean by linear correlation, and what do you mean by non-linear correlation? So linear correlation is the one correlation in which the values of two variables vary in constant ratio, vary in the same pace or vary in constant ratio. Then we call that the correlation is said to be linear. And if they are, if not, there is a no constant ratio, then we can say this is said to be non-linear correlation. So this is the main, that how it is linear and non-linear. But here my aim is to find the coefficient of correlation. Now let's start with this first method is scatter diagram method. In scatter diagram method, whatever points are given, we plot those points on the graph. Okay, if trend will like this, then we call it as a positive correlation, and if trend is like this, we call it as a negative correlation, and if trend is this, then we call this is 0. Okay, so if these points are near to close to each other, if these points are very close to each other, then we can say that the degree of correlation is very, very high. Means we can say that the values are closely related to each other. Okay, the change of one value will give effect to the other variable also. So this is scatter diagram. So this mainly this method we are not prescribed this method. Then we come to the Karl Pearson coefficient of correlation. That is method of our interest. Karl Pearson coefficient of correlation. Karl Pearson coefficient of correlation. So commonly we write it like a R, and the formula of this is, let us say let these values are to be given, some data values are to be given, say this is x1, x2, x3, so on up to xn, and corresponding to this, let us say I have some values are to be given, so on up to yn. Alternatively, let's say, or you can say some points are to be given, and I want to find the correlation. Correlation means that when one changes, how the other will change, this kind of thing we find. So Karl Pearson coefficient is R, and the formula is summation xi yi, I is from 1 to n, divided by under root of summation xi, I is from 1 to n, summation I is from 1 to n, yi. Now what is xi here? So this xi is equal to